Federated Data Mesh, the hidden foundation for trustworthy AI. Our presenter is Mohamed Mansour, Senior Data Engineer at Walter Group. Are data fabric and data mesh rivals or allies? Let's break down the apparent contradictions between these two buzzworthy concepts. They reveal how they actually complement each other. This session will challenge assumptions and show how combining both unlocks the full potential of modern data platforms. So Mohamed will give us this speech within a minute. In terms of the information for the rest of our day, we have a first coffee break at 11 till 11:30. So that will be the time for next coffee. Mohamed, are you ready?
Yes.
Stage is yours.
Thank you. What is the, how can I yeah. Thank you. Hello, everyone. I'm Mohamed Mansour. I joined Walter Group as a senior data engineer, but then later shifted to be a data architect. Quickly, I'm ex-Informatica, ex-IBM, and more or less I'm working and focused on data. So I delivered already data products or data platforms across 4 continents on 3 major data cloud providers, plus some stuff on-premise and still learning. So firstly, what is Walter Group? More or less, Walter Group is a family-owned business. It works mainly in logistics and supply chain. There is also some real estate and so companies and so on. Here is a group of companies that we have. More or less, it's not really that much marketed, I know, online or so, but it's somehow known for the German speakers. And a quick hint about the company was a partner of Germany to plan and organize Euro 2024, the football nation cup that happened last year. Jumping to the topic. Let's start with this one and then we'll go back. Well, some background here for the people who didn't interact that much with unsexy work of AI. More or less, data existed for pretty long time. And now with the hype of AI, everybody is talking about AI, but they somehow overlook what is needed to provide something that can be trusted, to provide something that can be resilient to build even this and so on. Previously, we used to have more or less centralized platform, one unified thing, either it's on-premise or on cloud, regardless of it's super fancy with many open source services, or just one platform where you pay for one license and then it's all working. But this unified thing used to have one centralized team, and this one centralized team need to do everything, need to go around, talk with business, do everything. And also when business asks for something, this business team needs to build a backlog of tickets for the technical people to sync data, to cleanse some data, to monitor some data, and so on. And that turned to be somehow a bottleneck, as when we started, the demand for this was needed just for the top management of every organization or so, but then it increased to be in every business unit, not just marketing, sales, finance or so, but also almost every team in the operations of every organization or so. That's why there were this kind of visionary, revolutionary concept of data mesh, which started 3 years ago. More or less, it was talking about that every business unit should have their own platform. Not just their own platform, as data mesh is somehow not just about platforms, it's more about the whole strategy, but also that every team or every business unit should have their own regulations, their own governance, their own more or less own the domain and the data of this domain, and they take all the responsibility of this. In this way, it's somehow something that unblock the teams, and they don't wait for someone external to do the things for them. But still, that's also included some challenges. But before jumping to the challenges, it's important to mention that in this way, it's somehow like we talk about that the domain experts, the experts who work in marketing or whatsoever, they decide the regulations, access what could be private data or so on their own, and that's something that enriched the business meaning of the data as well. But when this started, there were like many modern companies, modern organizations that were calling for services that can enable this on the major cloud providers or in the major services providers in general, and that lasted for quite long time. And it made sense for many of people that it take time to have services to apply this data mesh, because simply the cloud providers will not just throw away the services that they have, and they can just push or force everyone to move to data mesh. So between this very revolutionary thing and the quite old-fashioned stuff, we came to what could be like the middle point, the middle ground between both. Sorry for the mess in the slides. Yeah, but this middle ground, it somehow came to solve what could be like the challenges on both sides. So when we talk about data mesh itself on its own, it's quite costly, as it needs that every unit has their own architecture. It's quite mess, could be mess, not just mesh, because of the every unit has their own regulations about how to access data and so on. It could be that there are many things that's repeated, and the most important thing here that operational or operations systems or applications will have an overhead that every part of the architecture need to go and read data from there, and that's something that definitely overkilling. And we need to meet the reality, which is when we talk about data engineers, data science, or all those people related to data, it's already rare to find good talents across the whole globe, not just in some countries. And when we come to data fabric, it's already mentioned before that the centralized platform caused a lot of bottlenecks, and these bottlenecks also like can delay the business. That's why the solution was to have something that's called Federated Data Mesh, which is more or less to have the same centralized platform, but the ownership of the data inside this goes to the business domains. What do we mean by that? There is no replication in the data or in the architecture or the services or so. There is no extra cost. There is no extra hardware more or less needed here, or even extra code needed here. But this data itself, where it exists already now, the cloud providers worked on adding what could be a logical layer, a logical interface over this that separate between those data based on the company, based on the business domain or whatsoever. As an analogy and as an example of this that existed before, the concept of cloud providers itself is more or less the same data centers that exist in everywhere, like here in DACH, for example, in Frankfurt. But this same data center, you as company X, you will see only the hardwares or the servers that you reserved, but you don't see the hardware or the servers that relates to other company that exist also in the same data center also. So by adding this logical layer, the separation between what happened in the real life, what happened in the physical or in the physical hardware is somehow different from what the business team see. And the cloud providers that started with this, some of them like Google Cloud started with something like Databricks, Azure Purview on Azure, Lake Formation from AWS, and of course, when we talk about stuff like Snowflake or Databricks, those by default are somehow one platform, but then the regulations or the access stuff on it, that's the thing that you can play with to make every team look on their own stuff. But why we need this? Let's jump back to AI and the hype of AI. The AI that you provide, regardless of its leveraging the same LLM model that exists on your cloud provider, or building new machine learning, deep learning models, or whatsoever, those stuff are hugely dependent on the context. Those stuff can be biased, can be corrupted, can be bad just because of your data, good or not good. That's the key factor here. And when we think about federated data mesh or make the hardware or software or technical stuff centralized, and then we centralize there the tech expertise to focus on that. Meanwhile, the data with the regulations or policies to maintain or own this data and so on is somehow decentralized across the teams. In this way, we managed somehow to make the whole organization focused on their own point of expertise to maximize the value that they add. So by this way, the tech people can make sure that all the operations, all the CI/CD pipelines or whatsoever exist and work properly, monitored and everything. Meanwhile, the business can also enrich this data by some business meaning, like glossary terms, metadata, some context, some description, or whatsoever. Or even, or at least to add the BII tags that can define which data can be private data or privacy data, and which data that can be revealed publicly. In this way, the enrichment of the data itself that gets delivered across the whole organization at the end, it somehow makes the context itself more rich, more, it has some metadata, it has some meaning, and we can relate this to business and domains. So federated data mesh here in few points can more or less make it somehow or provide some domain context. So every domain expertise or domain admins own their own data. They provide data products, and I will not rehearse more about data products as Mario yesterday said enough about that. And we will have rich metadata from both sides, tech and business. At the end, it's also like a self-service platform or self-service access. You define the governance, you define how the people can get access, but then every domain, they give access to the people who really matter or connect to this data, or they need access to this data. The result of this is simply that the AI models that we talk about will have at least trusted data. So at least here, if we see something that could be suspicious, then we are sure that it's something that related to the model or the place where, like the infra where the model is running, but we are not suspicious about the data that we feed to the model. Talking enough about the theory, let's jump to the example, what we have in Walter Group. Let's jump to one use case here. We are in Google Cloud, so for us, Databricks is our federated data mesh service or so, or our logical layer here. Looking at the first diagram itself, the diagram is just show that we have like units, or we have different business domains, regardless of the name, product, sales, support, or whatsoever, but all of them simply like have some assets or some data that's saved either in BigQuery or in GCS buckets. So we talk about that technical-wise, we talk about the same services. Nothing changed, nothing shuffled here or went to other service. Maybe some shuffling inside the service itself just to define who owns what and so on, but at the end, we talk about the same billing that we pay every month or every year. But at the same time, this data are revealed or are discoverable across just some teams. That means that when we talk about some processes or some operations here related to security, related to like any processing or so, it also can happen within those domains, and then it's also separated from what happened in the other domains. It's independent on what happened in other domains. But to see or to know how this is even possible, regardless of its Google Cloud or whatever else cloud provider, it's more or less something that's really dependent on a mix of data catalog or the metadata that's available for the data itself, also like the security or which data that's reachable across or using this logical layer service or so, and then the normal logs and metrics related to the CloudWatch or related to any cloud provider. In this way, the separation can happen. In this way, the logical layer can be informed about the data saved in which service, and also this data belongs to which team, which domain that can be named. Is it product, is it sales, customer, or whatsoever? So as a bottom line here, we can say that when we look at the data itself, the actual data is just saved in BigQuery or in the buckets, but the people see only the data that relates to their team or their business unit. Jumping more, or getting more in details here, we can say that the centralized team, which in this way, like on our side, it's data ops team. In this part, or in this part, we talk about the pipelines, we talk about the CI/CD pipelines, we talk about the operations that need to be automated already, so every team can work or own their own stuff. So the central team defined the regulations of Databricks. The central team defined like the logs, the repos, for example, the infrastructure as a code, and so on. And out of this, we got some stuff that can be shared with the teams, so they can see their data, they can add their own analysis, they can just discover their data and add their data quality or whatsoever. To be more precise, that is the thing that we have now. In our team, in the central team, we defined or we created generally the BigQuery. We created the regulations related to IAM, or the who access what. And we defined also the code for Terraform, like the infrastructure as a code framework that we use. And then we combine this with some cloud logging. In this way, those stuff makes us always informed about who's doing what in each domain. But with this stuff, we also automated that the data can get synced with the accepted quality that we talk about, just to make sure that there is no duplication, make sure there is no nulls, at least in the critical columns, and so on. Afterwards, every team or every company in the organization can have their own data through these lakes. So, for example, if we called a lake that's called like LKW transport, in this lake, they have the separation within BigQuery itself that can tell them, here is the data that's ready to be used, this staged zone, and there is something that, here is the area where you can use it as your playbox, the place where you can run any back-end transformations or tests or so. And here is the public zone where you can put your data products or the data that you want to reveal with the rest of the organization. If you have any data quality or any transformation or so, you just need to add your code in one of the repos, and then the CI/CD pipeline already existed just to put it in the proper place and to inform you about the results of this and keep it monitored by your team. Same happen with the rest of the companies. Again, when we talk about this, the centralized thing, the things that's related to logs, operations, and so on are centralized. Otherwise, everything is saved in BigQuery. When people look at the BigQueries, they just see their own stuff, nothing else. That is the use case. It's important to mention here that it's not like we were pioneering or creating new concept or so. It's just like we were learning from what we saw before. According to Gartner, 85% of the projects in AI failed to deliver the promised results. According to Harvard Business Review, 78% of those projects failed due to data architecture issues. And according to IDC, 76% of those failed due to centralized data platforms. And this way, when we are an old-fashioned company that's 100 years old, that has more than 2,000 employees, we needed to learn to do our homework here and prepare ourselves for that. And when we talk about examples of those failures, we have IBM Watson Health or some other examples that exist across all Google. When we talk about success stories, Spotify and Airbnb, JP Morgan and others showed many use cases for that can prove that somehow the decentralization, more or less, can help in this aspect. Last but not least, how to implement, or what are the considerations to implement this. It's important to read or to feel the room. You know your organization better than anybody else. You can tell how mature is your organization for that. You can think about what are the things that need to be updated, what are the things that need to be somehow modernized, and so on. But the most crucial thing here, you need the support of your leadership. You need support of the leadership of the organization, and definitely that comes with you have to prove the value with this modernization that you talk about. Second step, you need to read the technical readiness or how ready your tech people for that. Which cloud provider, for example, they are familiar with, which services they are familiar with, what else they still need to learn about, and so on. But before you start anything with the technical deployment, it's really crucial to think about what we have on the metadata side and how to enrich this more, at least technical-wise at the beginning. And when you go to implementation, the approach can go as like you just need to prove your point, so you can have what's called POC of this, so you can just focus on one domain, for example, show the value there, show the success there, then focus on the other quick successes, focus on the other low-hanging fruits here to prove more your credibility and increase it even. And always focus on how to make the platform somehow self-service platform, how to federate the governance, how if you build something that needs to be today centralized, think about how later, maybe in the next year or so, this thing can be owned by different domains or teams. To measure all of this, to have metrics or success factors of that, you need to count like how many domains already are independent in this way. How easy is it to onboard the new domains? Is it really self-service platform or still people really dependent on you and stuff that's somehow repeated, routine, and have no meaning for you, at least as a tech person or as data strategist also. And that's it. Any questions?
Thank you so much, Mohamed. Is there any questions to our presenter? Oh, there are some.
The numbers about the failures which you presented, can you confirm? Okay, thanks. The numbers about the failures which you presented, can you confirm with your experience in your projects? Are these kind of real-world numbers? Because Gartner,
at least those numbers are published by the official websites of Gartner and so on. And if we talk, at least like from the personal experience, something like the IBM Watson Health project is what was running when I was there in IBM, and I saw it like getting dead in the last days. Other than that, from personal expertise, we always used to have a huge backlog of dependency tickets to just sync some data or transform some data or stuff like that. And when we just started to give the people some room where they can play on their own, it somehow reduced the amount of tickets. In previous experiences, in previous companies or projects, personally, I saw it like when everything needed to be sent to data engineering team to work on those stuff, it was like hundreds of tickets. When we just told them, you have this repo, just add your code there, add your Python script or SQL script or whatsoever, and then it will work on its own, the backlog shrinked by like 50% or so. So in short words, is like you need somehow to shift the team from data management or data engineering to data ops, just like that.
Hi, Johannes Ferner from Oracle here. I just would be interested, for how long are you operating this new setup, this new model in production? And what are the biggest issues in reality, you know? Because one thing is, you know, you paint down this cool architecture and then you hit reality and there may be some obstacles.
Yes.
And yeah.
Well, I work with Walter Group since 2 years, and at least this project of doing this data mesh, Federated data mesh started at least 2 years ago when I joined. It's still running. I can't say like it's fully done, but it's ongoing project. It's not like something that you finish and that's it, because you always have something new. You always have some expansion in the company, like to new market or new services or so, and then there is a new business domain that you need to include in this aspect. That's why in the implementation approach, I was talking about you need to think about what could be the quick successes to prove your added value, and then you go further with that. It's simply something that it takes years. It's not like one time thing, but once you finish the technical deployment of this, it's quite easy like to gain more successes here. The technical deployment itself can take, if you are really in really like complicated organization or quite old-fashioned organization like ours, it can take up to a year. But then you just work on like how to refine more your onboarding, how to gain more domains, how to show the added value, so you build the trade-off for the other business teams to join you as well, and so on.
Thank you.
Thank you so much. Is there any more questions? Oh, there's one.
Can you use the, sorry.
Okay, my question is, so now you have to do like working in the domains, but some use cases are where the domains need to work together.
Yes.
Like there's something in sales and operations, and basically, how do you, because the workflow mostly goes through several domains, how do you connect this mindset in the company?
Yes, okay, so we have 2 points of connections here. Or if we want to make those domains work together, we talk about either data that as it came from the operations applications, like some application of ERP or CRM or whatsoever, or we talk about data products. I will talk about both. For the data that's like just get staged or to be trusted data to use, we just share across the whole organization metadata layer. And in this metadata layer, people can see the table name, the column names, those stuff about metadata, and from there they can decide if it's relevant to them or not. Based on that, using some tags, they can enable this data for their domain, and then they can see the data across their domain. Meanwhile, unless there are some critical stuff or some privacy stuff and so on, those stuff then could already considered, so it hash or hide those columns. Meanwhile, when we talk about data products, the definition of data product is that it's data that you can easily like share with other teams through APIs or whatsoever, and then every business domain they are responsible to share the data product itself with the other domain.
That's cool. I think that we are fine now with the questions. I don't see any raised hands now. So I think that we can move on. Thank you so much, Mohamed, for your presentation. Once again, applause for you. Thank you.